and welcome to my talk on creating a single page application gateway with AppSync. My name is JK, I'm from Mechanical Rock, I'm a DevOps engineer, and I'd like to talk to you about a recent client that we worked for, creating a AppSync instance where we used AppSync as the application gateway for the front end to communicate with, which allowed our back-end services to be developed independently, and which allowed developers to move faster both on the front end and the back, and also independently. So just a quick overview. The talk will just briefly sort of deep dive into specifically serverless microservices. I'm going to start sort of at the top, quickly covering what AppSync is, an AppSync schema, what the resolvers are, the data sources, and then we'll get into some serverless microservices discussion with a bit of architecture diagrams. We'll also talk quickly about what the issues we found, some of the hidden problems which you sort of encounter as you get further in and longer into the development lifecycle, past the hello world or the blog examples that are usually there, and then also how it worked for our client in the real world. So what is AppSync? For those of you who don't know, AppSync is a fully managed GraphQL service that Amazon Web Services provide, and it gives you an endpoint that you can use for your front-end applications to connect to a single endpoint, and it uses the GraphQL language, which is slightly different to what you may be used to if you come from a REST background. Uses a special query type of language, which we won't really cover in this talk, but there are a bunch of other talks, I believe, that will cover it. It's serverless, so it's one of my favorite aspects of cloud computing. You only pay for when you're using it. If you're not using it, you don't pay. There's no servers to manage or patch or any kind of maintenance to be done. It's all managed for you. And you only pay as you go. So it also includes subscriptions and WebSockets out of the box. If you've ever had to set up a WebSocket server manually, you'll know what a pain that can be. So this is like a blessing, a real blessing. And you can combine data sources like DynamoDB, Elasticsearch, Lambda, HTTP. So if you want to do like a search service for a blog that you've been doing, you can put a whole bunch of key terms into Elasticsearch, and that can be a data source for you. Conversely, if you're wanting to go straight to Dynamo, you don't need to have lambdas, or you don't need to have external sources that will go into Dynamo for you. It's built in as part of the AppSync service, and you only request data that's needed by the client. This is more of a GraphQL thing than anything else, but essentially you, in the request format, you say, I want to go to this data source and I only need these things. So AppSync will go and fetch that for you and only send back over the wire the information that's actually needed by your client. So for example, if you want to say, give me this customer information and I'm only interested in the email address and their postcode, for example, you can get just that back. So there's less work needed by your front end. Sometimes with post and gets, you send some information over and then you get back everything, and then it's up to the client to disseminate what's needed. Whereas in this case, you say, oh, I only want this data back, and that's all you get. So it's a lot more efficient, especially for mobile services or services that are on low bandwidth connections. AppSync schema is a contract. So this, on the right hand side, there's a screenshot of from the Amazon Web Docs about what a schema looks like. So the schema defines how your AppSync instance will work, and it talks to how to structure your data. It uses types, and you can see there on the side. It defines your API, so it's self-documenting, and back-end developers and front-end developers both define how the data is used through the contract. So this is a simple to-do, and you can see that there's a mutation there, a query, and an enumerable status of the done and pending for your to-dos. So in this instance, if you wanted to get a to-do, you'd pass in how many you wanted to get, and it would return to you a list of to-dos. It talks, there's more information there about connections, but we're not really going to get into that for now. This is just giving you an overview of what an AppSync schema looks like. Resolvers. So resolvers is when you make the request, such as a query or a mutation, it will understand and you define how you want your service to resolve that data for you. So if you say, I want, the last 3 to-dos, it will understand how to get that information and return it back to AppSync so that your client can use that data. And you can modify it and change how these resolvers work without the front end needing to know. So as long as you conform to the AppSync schema, you can change the data source under the hood behind the scenes. So that will enable your developers to continue working what they're working on, but as long as you're still presenting the same information back through that AppSync schema contract, it'll allow you to change the back end. And you can retrieve from multiple data sources. So Resolver can go to different data sources to get that to satisfy the request. And it uses Apache's velocity templating language, VTL. So this is a quick example on the right hand side for data sources. So you've got DynamoDB, Lambda, Elasticsearch, and API Gateway. I've said API Gateway, but basically it's any HTTP. So you can either go to API Gateway or you can go to external data sources. Just a quick one as well. If the data source that you want to go to is not supported by AppSync, usually Lambda will cover that edge case. So for example, S3, you might want to retrieve a bunch of photos or pictures or something like that for the client, and Lambda can do that for you. The data structure is different to using the SDK. So if you've developed a bit of services using the AWS SDK, it's a little bit different, but it's not so different that you can't understand what's happening. So it's quite straightforward. It's a little bit different, but it's similar enough that it's not a huge jump to get to. Serverless microservices, right? So this is where we get into the meat of our domain here. So if you have a look, you'll see on the right hand side that we've got 2 domains in this instance, and we've got API Gateway talking to Lambda, which makes which pushes a message to SNS, and SNS then notifies all of its interested subscribers. This can be anything, but in this case, it's an SQS queue in the other domain, which then talks to a Lambda, and then you can either put data into a data store, or you can retrieve information from S3 or whatever. So in this instance, we have bounded, and so what I'm referring to here is bounded context. So you might have a customer domain and you might have a billing domain, and the customer has made a request or it's time for their bill. So there's a request that comes in, Lambda does something with that request. You can either store some information like I was mentioning before, then it talks to SNS, which will push out a message to SQS into the billing domain, and it will handle that request over there. How we use bounded context to communicate between the different microservices that we've got, just to keep the information clear between each, to keep the responsibility clear between each of the services. And in this instance, we maintained a monorepo of shared interfaces. So we were using TypeScript for this application, and by sharing our interfaces and types, we were able to keep all the data flowing between the services consistent for different data types and structures. So let's have a look at what this looks like in a wider context. So in this instance, we've got the GraphQL post request. So all requests from a front end, in this case we're using React, all requests to AppSync using GraphQL are post requests. So you post to GraphQL the data that you want back, which is why it's a post request. It comes through in a payload, and AppSync will go off to the resolver. And in this instance, we're using HTTP. So it's gone to API Gateway. API Gateway has invoked a Lambda, which whilst it does go to DynamoDB and SNS, it does those two things and then returns a status code to API Gateway, which returns to the resolver, which returns to the client. So we get a success message in this instance. So Lambda has stored some data in DynamoDB and it's posted a message to SNS because this particular request is interested, the next domain is interested in this particular request. And I'll just apologize in advance for my drawings. I hope they're understandable. I tried to make them clear. I don't really like using those architecture diagrams. I prefer to draw them myself. Personal preference, I guess. So in the other domain, we've got Lambda and SQS. And the Lambda is reading off the SQS queue. Similar concept from the first domain, but you can see how the flow of data sort of works its way around. In this instance, that Lambda is writing to Dynamo and also posting a message to another topic so that it can communicate with a third domain. And you can see the flow of data moving around the screen. This is the way that our microservices were communicating with each other. Using these bounded contexts, they were very clear about what they were meant to be doing, what they weren't meant to be doing, and when they needed to communicate cross-boundary, we were using queues and notifications to pass data around. So this meant that, for example, if AppSync wanted to query something in another domain, we have an API gateway set up on that domain. It then goes to a Lambda, satisfies the request, and if another domain is interested in a change or something that's happened there, it will send a message off through to the queue, which passes that data around the system, as you can see here. What the benefit of this is for the developers and for both front and back end was that the developers could change how these services operated under the hood, as long as they were conforming to the AppSync schema. The schema is the contract between the front and back end. And as I was mentioning before, as long as the back-end services or the resolvers will send data back in the interface that the front end expects through that contract, then we can change everything that's going on here behind the scenes without affecting how the front end works. If we wanted to add a change to how the initial domain works, as you can see in the first instance here, API gateway to Lambda, we could have that Lambda also calling out to something else, or we could have a stream coming off a change in DynamoDB, which would trigger a topic in another domain via SQS. So how this worked in, before we get into how it worked in the real world, I just want to quickly talk about the problems that we encountered. So at first, when we were first setting this up, the messages between services weren't type shared. So this meant that the constructs of data could be different. The data that we were passing around could be different. And so we were kind of getting a bit confused as to what data was being sent, and if something changed, how would a downstream service know about it? So we were using TypeScript, so we might as well make the most of that. And given that we were using a mono repo, we were able to type define the different data structures and include those in our application code for Lambda as it was passing data between services and receiving and transforming data. Messages could be lost. So as you saw in the previous diagram, the SNS topic could post a message to SQS, and then if the consuming Lambda of that queue was unable to process the message, it just disappeared. It couldn't do anything. So we made use of dead letter queues, and with the dead letter queue, we were able to see messages which weren't able to be processed, and we were able to handle those. You can also set up things like alerts or notifications to like a Slack channel or some other communication tool if you're wanting to notify developers when a message can't be processed. usually it happens almost instantly after deployment, because we go through testing processes in our pipeline. So once the application code is deployed, it runs through a series of end-to-end tests to make sure that our system is behaving as we expect. And if it's not, then those messages would appear in the dead letter queue, right? And so it would notify our Slack channel, and we would be able to pick up those changes and then address the fix before it made its way through to production. And we also didn't adhere to the single responsibility principle to begin with. So we found that our Lambdas were doing a lot, and like a lot of things. And so what we should be doing, and what we changed to further down the track, was we gave each Lambda one thing to do and one thing to do properly. So changing that meant that it was a lot easier to debug when something broke. We were able to find where the problem was and how to fix it. And I touched on it briefly, but the integration and end-to-end tests are crucial. So using those dead letter queues, as I mentioned, because we ran those integration tests in our pipeline against deployed code in a non-production environment, we were able to see those error messages straight away. And that was because the integration tests simulate a full end-to-end flow of our user using the system. So how it worked in the real world. I say the real world, but it's the virtual real world. It's a clear separation of back-end services. So we don't have one monolith. We have lots of small microservices that each are responsible for one domain. And we can change the interfaces to the data behind the scenes, and the users were none the wiser. The services can be changed independently, and there was no downtime as the front end as the front end service single page app was hitting one endpoint every single time. When we deployed a new version, the existing version would continue to function until the new version came in. And so there was no downtime for us. This is one of the huge advantages of serverless. And bounded context and single responsibility principles, we weren't treading on toes. So if someone was working on a particular domain, say the customer domain, we could continue to work on the billing domain without treading on their toes, because we were adhering to contracts and adhering to agreements of how data structures should be moving around, flowing through the system. All right, so that's kind of it. I've reached the 18-minute mark, 20-minute mark. So I just want to know, what questions have you guys got? Have you tried something similar like this? Did it work for you? Let me know. Cheers.